Good morning and welcome. Today we're going to be showing you the latest release of Kodiaks, our software vulnerability management tool. This release, version 2, offers a wealth of new features in response to feedback from our customers, and we're very excited by this release. Today's presenters will be Brianne O'Brien, our Director of Sales and Training, and our Chief Technology Officer, Ken Prohl. You've all joined in listen-only mode, so you'll be muted. Please feel free to send questions using the questions pane during the presentation. We're live, and we'd like this to be interactive, so if we can, we'll address your questions on the spot. Otherwise, we'll cover questions at the end. This webinar is being recorded and will be made available on our website later today. And now, I'd like to hand the presentation over to Brianne.
Thanks very much, Frank. Let's get started here by a quick review of the agenda for the remainder of the webinar. What we're going to be talking about today is a little bit about us, about Kodiaks Inc., followed by some of the problems that Kodiaks is able to address. Following that, Ken is going to be discussing application security testing techniques such as manual code reviews, static application security testing, and dynamic application security testing. That'll be followed up by a review of the Kodiaks benefits, certain usage scenarios such as Kodiaks' interfaces with Jenkins continuous integrations systems, Eclipse integrated development environments, and issue tracking systems, as well as a review of the new features in Kodiaks version 2.0. We'll follow that up by a demonstration of Kodiaks, and at the end we will answer and field any questions that you may have. Please feel free to also ask questions as we go along, and we will try and integrate that into the presentation. So a little bit about Kodiaks Inc. Our mission is to secure the software supply chain and to make software as secure as possible, and to find vulnerabilities in the code before attackers do. Toward that end, the Department of Homeland Security has funded, and we have developed innovative application security testing solutions. We have offices. Kodiaks Inc. has offices in Northport, New York, and Clifton Park, New York, just outside of Albany. So we have developed these innovative application security testing solutions. The first one is Kodiaks. This is a software vulnerability management and application security testing tool system. You can buy this commercially, and it's also available within the Software Assurance Marketplace, otherwise known as the SWAMP. The SWAMP was funded by the Department of Homeland Security, and you can find more information about the SWAMP and its facilities and opportunities to support application security testing at continuousassurance.org. We also have another technology called CodePulse. We're involved in the open source community, and this is an open source product. It is a system to help configure and use penetration testing tools to generate more thorough and comprehensive penetration testing results. It's freely obtainable from codepulse.com. We are also a co-organizer of the local Long Island chapter of the Open Web Application Security Project, or otherwise known as OWASP. And OWASP is an excellent resource to learn about application security testing. Our other technology is swiviz.org. This is a website that we host that depicts the common weakness enumeration in a visually intuitive way. If you are new to the application security testing and want to learn more about common weakness enumeration, swiviz.org is an excellent resource to help you do that. So why do we care about application security? Well, the issue really is being able to protect your company against data breaches. There have been numerous data breaches over the past several years. In fact, there are 350 million accounts that have been impacted just by data breaches, the data breaches shown in this slide. More breaches have occurred in recent months, including attacks against the government and commercial business. And the annual cost of cybercrime is over $400 billion and climbing. Clearly, this is a very critical problem to our infrastructure. What we know is that non-secure software is the underlying cause of many of these breaches that have occurred. In fact, web application attacks is the favorite method of organized crime to strike at your IT infrastructure. The Verizon data breach report released just this year said that organized crime became the most frequently seen threat actor for web application attacks. And these attacks accounted for 31% of the breaches experienced by the financial services industry alone. Now, the reason why you need to be concerned and focused on application security testing is because software flaws are the root of most cybersecurity incidents. The numbers vary, but the Department of Homeland Security says that approximately 90% of the security incidents are the result of exploits against defects in software that were primarily put there inadvertently by poor software coding practices. And they are there, and people don't know that these vulnerabilities are there, which is why there are now bug bounty hunters. These are folks who get paid, basically, to find software vulnerabilities before attackers do. Google pays white-hat hackers up to $20,000 to find vulnerabilities in its web browsers. Microsoft offers as much as $150,000 for vulnerabilities in their software, and United Airlines is now paying bounties in air miles or frequent flyer miles based on the bugs that folks can find. So this is clearly a problem, and this is clearly a problem that we hope that Kodiaks can address. So now I'm going to turn this over to Ken Prohl, who is going to talk about the types of application security testing that you can perform.
Unmuted.
Hello. So I'm curious, what type of application security testing are you doing? Please type your answers in the chat box. I'm curious what everyone on this call, what kind of testing people are doing. See if we can get some feedback from people. There's three. As Brianne mentioned, there's three types of application security testing. The first one is manual, and this is where a human sits down with the application and looks for vulnerabilities. They typically start by getting an understanding of the architecture and threat model, and often have access to both the source code and the running application, so they can do things like code reviews or penetration testing. Oftentimes, DAST tools like Burp are used to help with manual testing. The things found with manual testing are often highly accurate and useful for developer remediation, but it's really difficult to scale. SAST, or static application security testing, is white box testing that analyzes the source code for potential vulnerabilities. The problem with SAST is you typically get a lot of issues that need to be triaged, and oftentimes many are false positives or issues that are not exploitable in the running application. It's really scalable, however, and can be easily automated, for example, setting up as part of your continuous integration builds. DAST, or dynamic application security testing, is black box testing that looks for vulnerabilities from the outside, just like an attacker would. It often is used later on in the development cycle, since a running application is required. Each of these techniques have their place. There are certain things that DAST will find that SAST simply cannot, like information leakage, for example, and vice versa. The same is true with manual testing. You really should be using multiple testing techniques. And with Kodiaks, the results of all these activities can be shown in a single unified interface, so you don't have to hop around between different applications as you are working on fixing the issues detected. But even with each technique, you should be using multiple tools or multiple human analysts. There's no single tool that can give you full coverage. Each tool finds different types of problems, and some excel in certain areas. On the top right is a study done by NIST where they ran 5 tools on a bunch of applications, and they found that 84% of the findings were unique, meaning they were identified by one tool. NIST has done many studies in this area. It's called the SATE, or Static Analysis Tool Exposition. The NSA Center for Search Software has also done research in this area. They created a test suite called Juliet that contains several million lines of synthetic code and over 60,000 test cases with known vulnerabilities. They ran a lot of tools against it and found that the average tool discovered only 14% of the known vulnerabilities. More recent work is the OWASP benchmark project, which is being led by Dave Wickers of Aspect Security. He was also the lead for the well-known OWASP Top 10 list. They have over 21,000 test cases focused on security in Java applications. And the nice part about this test suite is it's well suited for testing both SAST and DAST tools. Right, here's the results of 2 tools. On the left is Find Bugs with the Find Security Bugs plugin. On the right is the freely available DAST tool, OWASP Zap. The best results for a tool are if they fall in the top left, meaning it finds everything and has no false positives. We can see Find Bugs was perfect at weak random issues, where Zap couldn't find any. And Zap was perfect at insecure cookies, where Find Bugs did very poorly on. So it makes sense to use multiple tools to improve coverage, but there isn't an easy way to do this. Each tool has their own way of describing their findings, which, as popular blogger in the space Jim Bird points out, is very challenging and time-consuming. But the fact that these tools work differently is a good thing. When using multiple tools, you really need a way to correlate the results and remove duplicates so that the user doesn't have to go through the same issues multiple times. But how can you do this? So the common weakness enumeration, or CWE, is maintained by MITRE, is a common dictionary of weaknesses and is what can be used to help with correlation between tools. Most commercial tools report a CWE for each finding, and for the open source tools, the Kodiaks team has manually done that mapping for you. In prior versions of Kodiaks, we correlated based on exact CWE and their matching line number. But what we learned is matching only on CWE doesn't provide the best correlation. How many people feel they have a good understanding of the CWE? It's pretty simple when you have a single CWE, but if you look closely, it's actually quite complex. If you print out the CWE, you're talking about over 1,500 pages. And the CWE is hierarchical, as shown here in our cweviz.org visualization. This is actually showing the highest level nodes called categories. Mapping to the, that's only a subset of the actual CWE. The CWE is quite complex. This is showing a graph of just one view of the CWE. And if you look at a particular CWE, there's different types that they have within the taxonomy. So you have things like views, categories, classes, base, variants, elements, composites. It can be quite complicated. And there's different relationships between these CWEs. So it can be a bit overwhelming for someone to have to map results. And if you ask 5 people what CWE a particular issue should be mapped to, you may get 5 different answers, and each one may be correct. Here's one example. 2 CWEs that are related to concurrency. A vendor can choose either one and still be correct. Or take a look at these cryptographic issues. We see some vendors choosing the top level CWE, which is 310, while others are being more specific and choosing one of the child nodes. So for correlation, what you really want is some fuzzing and say if anything related to cryptography issues are found, then correlate. We thought maybe we could just use the CWE hierarchy as a method for doing this, but sometimes similar weaknesses are at completely different parts of the CWE tree. Here's an example. Generally speaking, you can see that memory leaks are in several branches. Depending on which branch the user navigates, he or she may map to a more general or specific CWE, but it doesn't map directly to someone else's choice because they chose a different branch. And there's another problem. The CWE is not always specific enough to map every tool result. There are about 719 specific CWEs, but a given tool might contain over 300 rules. So there's no way you can map all the CWEs, all the tool rules to a given CWE. There's just not enough CWEs, and the problem is even worse when you're dealing with multiple tools. And here's one example. Findbugs and PMD both have a rule that checks for the use of temporary object to convert a primitive to string. There really isn't a CWE that covers this. One can map that to CWE 398, which is a general code quality issue, but then you might wrongly correlate with different code quality issues. Another example in the security area is that XSS, which there's 3 common types of XSS attacks, is reflected, stored, and DOM-based. But if you look under the CWE hierarchy, there's only one top-level CWE that covers all of cross-site scripting. And so if you wanted to be more specific, you would be out of luck. So our solution with Kodiaks 2.0 is that we ship with a default rule set for correlation configuration. And this has a bunch of different rules that are configured to map different CWEs and different specific tool codes to more common groupings. So here we can see SQL injection. We have comments in there, and all of this is customizable, so the user can edit both the descriptions and how the correlation logic is done. So there's no magic. You're in total control. You can come up with your own correlation logic, stick with the default, or copy what we have and go on from there, depending on your needs. So this is an example showing duplicate entries being merged into one, so that improves the triage efficiency, so you don't have to go through each of these issues one by one. So I want to step back a little bit and do a quick review of what Kodiaks does. Here are some examples of the types of issues that can be detected by Kodiaks's bundled tools. You can see that there's both quality and security issues. So Kodiaks focuses not just on security, but also on quality, and this is an example of the types of issues that can be detected. And research has shown that improving quality of code leads to more secure code. It also makes it easier for both the users and automated tools to analyze. So it's important to not just focus on security, but also improvement of quality. This is the list of static analysis tools supported by Kodiaks. It's a mix of open source and commercial, and we are continuing to add new tool support. Kodiaks takes in the results of all these tools and integrates them into a single interface. So rather than having a single instrument, the idea is instead have a symphony, taking the best qualities from each tool. These are the 12 freely available tools that come bundled with Kodiaks. We take care of installing, configuring, updating, and running these tools. And that turns out to be quite tricky. Many of these tools have their own peculiarities that need to be addressed to get good tool results. Our Kodiaks Enterprise Edition can also take in the results of these freely available tools. Some of them are good for mobile development. We just recently added support for Android Link with our 2.0 release. And we also support a wealth of commercial static analysis tools as shown here. For 2.0, the enterprise version, Kodiaks now supports DAST tools, with more DAST tools planned for future releases. This is a list that we currently support, and if there's something not listed here, please let us know. And the bundled tools that are in Kodiaks support 7 different languages. If you're using other tools that support languages not listed here and taking in the results, Kodiaks can still be used to show those results. It's really language agnostic from a display perspective. Again, if you're interested in support for another language like PHP, please let us know. So now I'm just going to go over what's new in Kodiaks 2.0 and then provide a brief live demo. So the first thing, big thing was the addition of DAST tool support. So we now can take in the results of DAST tools, including specific information that is unique to DAST tools, such as the parameter of the attack. A lot of tools will also show the different variants, so different URLs and parameters that were used for the attack, and the full request and response for each report. We also have the ability to do the merging of duplicate results. In prior versions of Kodiaks, we would just show that correlation, but we wouldn't merge the results. And as I talked about, we now have a customizable correlation logic, which is greatly improves on the amount of correlation that we now can have. We've also integrated with the JIRA issue tracking system. So now you can look at results within Kodiaks and assign them to JIRA issues for the development team to work on remediation. We have the ability to incrementally data upload, so you can, rather than having to give Kodiaks all of the results at once, you can now just add a single tool result rather incrementally. We also support findings, mapping findings to different industry standards, such as the OWASP Top 10, the SANS Top 25, the CERT coding standards, and several other ones, and we plan on adding support for others in future versions. We added a search filter, so you can search on things like CWE or file name. And we now have the ability to carry over triage settings and comments from tools. So if you're doing analysis within the commercial tool, for example, like Fortify or Veracode, and you're marking things as false positives or adding comments, those comments will be carried over into Kodiaks when you import. And as I mentioned, the Enterprise Edition now supports Android lint as an input type. So these are the users that we've targeted for Kodiaks. Some other tools are focused solely on security, but with Kodiaks, we designed it to be more open and allow different users to be able to collaborate together. Quickly going over the different types of users, developer is the one that understands the code very well and is responsible for remediation, but usually isn't as security savvy and may not be familiar with the security tools. A security analyst or QA engineer understands the tools and the code somewhat, and often responsible for setting up the tools, running them, triaging the results, and working with the development team on remediation. We also have the security auditor, which is typically outside the organization. These are people that have a suite of tools and they don't really know much about the application. They know a lot about the tools, and they're given the application and asked to provide their assessment. And finally, the CISO, or Chief Information Security Officer, or General Software Manager, any kind of management level, we have that user as well, as a way for them to see an overview of the security state. So looking at the workflow of how someone could use Kodiaks, there are many ways to get data into Kodiaks. You can just zip up your code and drag and drop into the web UI. That's one option. We also have the option to pull source directly from Git. And my preferred approach is to use a continuous integration build server, such as Jenkins. This way, issues are found early in the development process. And we have a plugin for Jenkins that you can use for that. We also have a REST API, which can be used for other continuing integration systems or custom scripts that you're using. So you can both upload and pull out the results from Kodiaks using our API. And lastly, we have IDE plugins for Eclipse and Visual Studio, and that allows you to push the source code to Kodiaks for analysis. So as you're doing your development, you'll be able to see if there's any vulnerabilities that are being introduced before you continue. So catching things much earlier on in the development process. So all of this data can be fed into Kodiaks and correlated and normalized, and we have the different user groups that can then collaborate, triage, and work on remediation. And then these results can be exported out in different ways. So we have support for XML, CSV, or PDF reports. You can send things back out to the IDEs, so Eclipse and Visual Studio, and that's including the commercial results that commercial tools that you might be using, and DAST tools as well. And now we also have support for JIRA, so that you can assign things into JIRA and use the existing workflow that your development team may be using. So without further ado, I'm going to switch over to a live demo. I'll cover some of the existing features for people who may not be familiar with it, but a lot of the demo will be highlights of the new features in 2.0. So I'm going to start out by looking at our Jenkins plugin. So again, Jenkins is a continuous integration build server. It's typically used to run a build on your application, run unit tests. You can set it up your commercial tools, commercial static analysis tools to be run. And we also have the Kodiaks plugin that you can then have Kodiaks run our bundle tools as well as take the results of the commercial tools. So here we configured the URL, the API key, what project we're going to be working on. So this demo I'm going to work on WebGoat, which is a project from OWASP that has known vulnerabilities in it. Select the source and binary files that I want to upload, and then the commercial tool results. In this case, I'm using checkmarks, WebGoat, and AppScan as my commercial tools. I can also set up build conditions, so I can say, if a new high severity finding is found with this build, please, break the build, email the developer, and they would immediately know that they need to resolve this. So this is a way of having this in a continuous fashion. You can have it set up on every build, maybe every night, whatever works best for you. So I've already done a build. You can see the results here, shown in Jenkins. So we can see a summary that shows a breakdown of severity, how things have changed over time. And then we can see on the right as well as a trending graphs that show you breakdown of severity and status trend. You can see that things are on a downward trend, which is a good thing. And we could also view the results in Kodiaks. So this is a way of now going through the triage process. So if I'm a security analyst, I would want to go through this list, which we can see there's 5,215 findings across these tools, and figure out which ones I want to focus on. Let me just give you a quick overview of this interface here. We have a table on the right. It's broken down into different columns that you can sort on. So the things like the rule, the tool, CWE, code base location, and status. So the status is something that you can set as you're going through the triage process. You can maybe mark things as false positives. You can assign it to different people. And this can also be done in bulk. So if you have a group of things, you can operate on that in one entity based on your filters. The filters are shown on the left here. You can see a bunch of different things. It's just the rule, and these are the customizable rules that we've shipped by default, which is used for correlation. All these filters now are resizable in 2.0, and you can also see the tools that were used, and the bar charts indicate the count. So we can sort by count. We can see which tool has the most findings, and you can drill in on each tool and get a better perspective of how each tool is breaking things down. We have severity, which is normalized across the tools, and various other filters that I'll go through as a demo. One of the new things that was added is a search capability, so I can search on CWE, for example. CWE89 is SQL injection, so you can see that I'm looking at just the SQL injection findings here. You can also search on location or finding ID. So if I'm a security analyst, I may have things set up in my build server that's running continuously, but I may also be doing periodic scans. Maybe I'm, for example, doing a Veracode analysis or running something like ZAP, which is a DAST tool. So I'm going to bring in that data as well. So I'm going to go over here to the project page and select outputs from both Veracode and we'll use burp in this case as my DAST tool. So I've selected those two output files, and I've told Kodiaks to analyze it. It detected Veracode and burp. It's now correlating those together, bringing into the rest of the data within Kodiaks, and now the results are available. So where in prior versions of Kodiaks you would have to upload everything, now you can just give it the new results as you've seen here. So now we have 5,252 results. And we can actually see that some of them are actually already marked as false positive, and that's because the Veracode file already had some triage that was done. So again, both status changes and comments will be carried over from the tools that support that. So let's do some triage. So we see up here top, we have 5,252 findings. Now, if you look at the actual tool results, there's 6,565. So already, based on the correlation logic, we're saving a lot of time by deduplicating a lot of the findings. So we're dropping the number by over 1,300 findings. And this is actually with our preliminary version of our rule mapping. So this is going to improve a lot more once we finally release 2.0, which we're expecting to release in early October. So this is already a great savings of time by being able to merge together the tool results. But still, 5,000 is a lot to go through. So there's different ways that you can filter, as I mentioned before. You can look at code base location. Maybe there's a part of the code that you want to focus on that's more critical. If you look at the tool overlap, we can see a breakdown of which results are unique. So you can see that a lot of them are unique to just one tool, 85.6%, but then there are a bunch that were found by multiple tools. We can focus on that. But first I want to look at the standards filter. So right now it's looking at a list of all the different CWEs, but we now have support for different standards like the cert coding standard, CLASP, We have the SANS top 25 and various other ones. In this case, I'm going to select the OWASP top 10 list. So it's showing now 16.7% of the total findings are within the OWASP top 10. You could break down further and look at each particular category. But I'm just going to select the whole OWASP top 10, which brings us down to 876 findings, which is much more manageable. And I'm going to further refine things by looking at results that have been found by 4 or more tools. And I'm doing that because there's probably a lot more confidence in the results if a lot of tools are reporting the same thing. And now I'm left with just 22 findings. You can see that there's a lot of SQL injection. And then on the bottom here, we see a cryptographic issue that was found by checkmarks, findbugs, Fortify, and Veracode. If I look at the actual count here, we see that checkmarks found 2, Fortify 1, findbugs, and Veracode for a total of 5 results across 4 different tools. I'm going to drill in on this particular finding. And so we can see here, again, it's giving us some information about the result, and it's a merged finding. And we can see here the different results from the different tools. So we can see that they're all using different language for the same kind of problem. And they're actually using different CWEs as well. So we see CWE 328 is being used, which is a reversible one-way hash. 327, which is the use of broken or risky cryptographic algorithm. Fortify used 310, which is the broad category of cryptographic issues. So you see already how the correlation is helping us merge different tool results. If I actually jump to the actual line of code where this finding is, we can see that something with MD5 encryption being used, which is insecure. And so all these tools are reporting it. We can see here on the left that these are all merged into one finding. As I'm looking at this file, I can take a look at what else was found. So we have some invalid pointer issues that were found by both Fortify and findbugs. So this is a good way of analyzing other things that are going on within this file. At this point, I can use the built-in tracking system, so I can assign it to developer. I can add a comment right here, which will be updated live in real time so people can chat back and forth. But for this demo, I'm going to demonstrate the new feature, which is the integration with JIRA. So I can create a new issue, or I can associate with an existing JIRA issue. In this case, I'm going to create a new issue. And we can see the issue was pre-populated with summary, priority, some description which you can override and set to something else if you like. So I created the issue. You can see it shows up in the activity stream, and a new association was made here in the status section. It's currently marked as to do, so a developer can come in and see this new ticket that was assigned to them, and maybe they go and look at the problem. They can click into the Kodiaks findings as well to get more details on the particular issue, and eventually they're going to mark it as done, and saying that they fixed the problem. And then if you go back into the details page, you can refresh the current status and see that things have changed. And we also have the ability to do periodic updates, and that's configurable. So the first thing I did before this demo was I set up a link to JIRA, told it the URL and the password, username and password I want to use, and I've also can configure an update frequency. So you can say, update every hour or twice a day, and so this information will be updated automatically. But you can also do a manual refresh. So in this case, I can see that this is now marked as done. And this information is also available from the triage page. So you can take a look at the, just going to show some more results here. The new issue tracker status. And we can see all of the issues that are marked as done. I'm going to check that off. So now as a security analyst, I can come in and say, okay, these are all the issues that the development team has determined is fixed. I may, at this point, want to rerun some of the tools to confirm that it's fixed, or do my own analysis before I actually mark it fixed in Kodiaks. Or the things would actually disappear if you ran all these tools. Kodiaks would automatically say, this issue is no longer there, and it'll mark the issue as gone. So that's good. So you can go through one by one and assign things to JIRA. But another thing that you might want to do is bulk up various different issues together under one JIRA ticket. So that's take a look at the SQL injection findings. So now I'm focusing just on the 45 SQL injections, and I can do a bulk operation and create an issue for all of these findings. So there'll be a single JIRA issue associated with 45 findings within Kodiaks, and you can see that the table updated, and we have all of the issues here that are shown. And the issue tracker status filter is also updated, so now we can focus on the ones that are either done or in the to-do state. So I think I covered a lot. The one other thing we have the ability to do is hide things that have already been kind of resolved. So again, I mentioned that there's some false positives that were brought in from Fortify that are currently being shown. I can hide those by clicking on this filter so that you can only focus on the things that are currently need to be triaged rather than the things that have been fixed, ignored, or marked as false positive. That concludes the demo. I didn't cover some of the other things. A lot more features within Kodiaks. Like the IDE plugins could be used to also look at the results. This focused a lot on the new features in 2.0. And I'm gonna, at this point, turn it back over to Brianne.
Actually, I'll take it. Thank you, Ken, and thank you, Brianne. Some of you have sent some questions through during the presentation, but I will encourage the rest of you, if you have questions, please send them through. We'll try to get them. We have a few minutes left. The first one I'd like to ask is one that a few of you asked. It seems like the issue tracking is a pretty
That's a good question, Frank. So yeah, we are looking to integrate with other issue tracker systems. So we've developed our integration in a generic way so that other issue trackers can be integrated. We've gotten the most requests for JIRA, and that's why we chose that one first. But we're looking for feedback on other issue trackers that you might be interested in. Things like Bugzilla and TFS are also popular. So it's really based on the feedback that we get from our users. And so, like I said, we're really interested in hearing what kinds of other issue trackers that you're interested in.
Okay, thanks. And again, folks, if you have interest, you have an issue tracker that you favor, please send it through the questions pane and we'll keep track of that for you. Another question that a couple of people have asked related to the correlation logic is, Ken, what sort of improvements have you seen over previous versions of Kodiaks now that you have this correlation logic?
Right. So, yeah, like I said, we're still working on finalizing the correlation logic, but even in our early versions, we're seeing a tremendous improvement in the correlation where in the past, just looking at a specific CWE, one project that I'm thinking of, we had about 3 different findings that were merged, and then with the new technique, there's close to 300. So this is going to really improve correlation and deduplication, and really excited about this new feature and curious about everyone's feedback on it. So.
Okay, and time maybe one last question here. One of our listeners is asking whether there's any sort of high-level dashboard view of this type of information in Kodiaks.
So yeah, a dashboard is something that we're planning on future versions, probably about 6 months out on that at least, but we have gotten requests for having more of an overview kind of thing, be able to look at trends over time. So for example, looking at cross-site scripting and seeing what kinds of, how that's trending over time, and maybe help with training and things like that. So that is definitely on our roadmap and something that we're looking to add shortly.
Okay, Ken. We also have a couple of questions from the audience. One is, are Flash and ColdFusion supported?
We do not, the bundle tools that we have do not cover Flash and ColdFusion. If you're using one of the commercial tools that support that, we would be able to take in those results. But we don't currently have any bundle tools for those languages, and that's something that we can look into adding support for if there's tools that exist for that.
Along the same lines, Ken, one of our audience members is asking about Fiddler 2 or Fiddler 4 results, if they're supported.
That's a good question. That's not currently supported. We will look into importing those results as well. I'm not sure if Fiddler actually has a report that tells you about particular vulnerabilities or alerts, but if it does, then that might be a tool that we can integrate with. I know that it's definitely very popular for penetration testers and application security specialists. So.
Okay, Ken, another question from our audience is, do you recommend users combine Kodiaks with other commercial tools like AppScan?
Yes, definitely. So using both the open source tools that we have bundled within Kodiaks and commercial tools such as AppScan is a very good idea. We have seen that there are gaps between the two, so you're going to find things in AppScan that you're not in the open source tools, and vice versa. And that's really the power of Kodiaks. You can take in the results of AppScan and integrate it with other results that we have. Some commercial tools have limitations on the languages that they support. For example, I'm not sure if AppScan supports Ruby, but within Kodiaks, we do have support for Ruby, so that allows you to sort of complement what you're doing within AppScan.
Okay, Ken. Another question. Is the ID shown in the table globally unique across multiple scans for multiple applications? Is the ID in the table globally unique across multiple scans for multiple applications?
So everyone is working off of the same Kodiaks server, and so if they're all connecting to the same project, they would be able to see the same results and be able to refresh things and bring up a lot of the same kinds of information that I showed in the web UI, like add comments and change triage and things like that. If you were looking to have it more isolated, you can set up a separate project that is, just for a particular developer, and they can work in their own sandbox. But it is meant to be used in a collaborative environment where, yeah.
Okay. Does Kodiaks keep a history for issues that are found across multiple scans?
Yes, absolutely. So everything is stored within Kodiaks for historical analysis. So if you were to mark a particular finding as false positive and you do another scan, that will be maintained as being a false positive. If you add comments, the same thing. Everything is persisted. And we also check for things that are new or gone since the last scan. So Kodiaks has the ability of showing you just the new findings, which is really powerful, because if you're looking at a legacy application, you may want to start out saying, okay, from this point forward, I'm just going to focus on the newly introduced things and focus on those first before we start looking at all the old code.
Alrighty, Ken. Is there a limit to limit of scan storage? Is there a limit of scan storage?
So Kodiaks is meant to be stored on your own servers currently. So it is a on-premise deployment, and we have an installer that can quickly get you up and running. It's a typical web-based application, and the storage is based on the whatever kind of server that you have available. And so if you have more storage, then you'd be able to scale out to more projects. It's really based on your server configuration.
Alrighty, another question out there is, what are the parameters that makes it a unique issue or finding?
Okay. So like I said, the correlation is configurable, and you can set up your own custom rules and determine how to correlate. And the current UI for that is allows you to specify CWEs. So you can say, this group of CWEs is going to be related to this rule. You can also specify a particular tool code. So, find bugs, tool code XYZ, and AppScan tool code XYZ is going to be mapped to a particular rule. And then we look at the location of that finding within the source code. Or for DAST results, we look at the URL and the parameter that is being reported.
One more question, Ken. Are the reports editable or customizable? Can they be imported into Word?
So the reports are currently pretty fixed, except what data goes into them. So you can set your filters, and then when you generate the report is going to be based on the filter selection. And we have PDF reports, CSV reports, and XML reports. So the XML reports, you can use that and translate it into other formats. And the CSV reports can be opened up in something like Excel, and you can generate other kinds of analysis with that. And then we also have the REST API, which would allow you to do an automated way of pulling out the results and bringing them into other systems. Maybe you have a SIM or a GRC system that you're looking to get the results into. That would be what you could use. But we don't have too much customizability with the reports currently, but if there's particular functionality that people are looking for, we'd like to hear more about that.
Is it possible to set up report templates for the PDF reports?
So not currently, but that's something that we can look into.
I've got one last one that someone asks over here, and it's a good high-level question. Do you recommend that users combine Kodiaks with other commercial tools like AppScan, or is it powerful enough as a standalone tool?
Yeah, the question, we took that question before. Yep. It is good. It is a good question.
I apologize.
The answer was definitely yes. Definitely want to. Definitely good to combine commercial and the bundle tools within Kodiaks.
Okay, Ken, another question just came in. Does Kodiaks have a show in browser feature for cross-site scripting findings?
So I think the question is asking if you can kind of like replay the cross-site scripting issue within the browser, and that is currently not an option. The other way I'm thinking, the question is, what kind of information do we provide in the cross-site scripting? And what we will provide is detailed description of the cross-site scripting, as well as any information that each of the tools are providing. And so a lot of the tools will provide detailed remediation advice and examples, as well as the full request and response that they use to generate the attack. And you can take that request and replay that on your own, but that's not something that is automatic that can happen within Kodiaks.
Again, the questions keep on coming in. Is there an API to integrate to an external database?
Instead of to JIRA?
Not currently. That's a good point. Yeah, this is our first iteration of the JIRA integration. I would imagine that kind of functionality would be part of our REST API. But I don't think that that's currently available in the API, but I would have to check that out. That's something that we can look into.
Okay. Okay, I think that might be.
I think that's it. That's all we have time for, and thanks to everyone who attended and for all the great questions. By the way, if you're planning on attending AppSec 2015 in San Francisco next week, please stop by our booth and say hello, and you'll get a much closer hands-on look at CodeDX 2.0. Again, thank you to Brianne and Ken, and thanks to all of you, and this will be posted onto the website sometime later today.
Thank you, everyone. Have a good day.